What if I told you there's an invisible script that dictates every single movement in the universe? I mean everything, from an apple falling off a tree to a rocket blasting into space, the exact same rules are at play. Today, we're going to learn how to read that script, and trust me, it reveals a universe that's way stranger and honestly a lot simpler than you might think.
So let's start with a question you probably feel like you already know the answer to. You kick a soccer ball, it rolls across the grass, and, well, eventually it stops. Simple enough. But why? What's your gut reaction?
For most of human history, our intuition was pretty straightforward. Things just run out of steam. They get tired. It seems totally logical, right? The natural state of everything is to be perfectly still, and motion is just a temporary struggle against that.
Well, that fundamental feeling, the one that seems so obvious in our everyday lives, it's completely and totally wrong. Stopping isn't the natural state at all. In fact, the universe is trying to do the exact opposite. The truth is, everything is governed by this invisible script of motion, a set of rules first laid out by the one and only Sir Isaac Newton. And by the end of this, you'll be able to see these rules in action literally everywhere you look.
The very first rule of this script is all about a property that everything has. It's a kind of cosmic stubbornness. Yeah, physicists call it inertia, but I just like to think of it as the stubbornness of stuff. Okay, so here's the mind-bending part. Newton's first law tells us that an object in motion wants to stay in motion, forever, in a perfectly straight line. The only thing that ever stops it is some outside force messing with it. That ball on the grass, it only stops because of the meddling forces of friction from the grass and the air pushing against it. If you kicked that ball in the vacuum of space, it would just keep going and going.
This makes it personal. Think about it. When a car slams on its brakes, you fly forward. That's not some new mysterious force pushing you. No, that's your own body's stubbornness. It's inertia, trying its best to keep traveling at, say, 60 miles an hour. Your seatbelt? That's the external force that thankfully says, nope, you're stopping with the car.
Now, this stubbornness, this inertia, it comes directly from an object's mass. And this brings us to a really critical point you have to get right. Mass is your physical identity. It's the amount of stuff you're made of. It is constant no matter where you are in the universe. Your weight, on the other hand, is an interaction. It's just the force of a planet's gravity pulling on your mass. So you have the exact same mass on the moon as you do on Earth, but you'd weigh a whole lot less up there. Okay, so objects are stubborn, we got that, but they're not alone. The next rule in our invisible script reveals that in the universe, forces always come in pairs. There's this constant universal pushback.
You know the famous line, for every action, there is an equal and opposite reaction. But wait a minute, this leads to a classic puzzle. If the forces are always equal and opposite, how does anything ever move? Shouldn't they just cancel each other out? Well, here's the secret. The action and the reaction forces always act on two different bodies.
This table breaks it down perfectly. When you walk, your foot pushes the earth backward. That's the action. In return, the earth pushes your body forward. That's the reaction. See? The forces are on different things, you and the entire planet. That's why you accelerate forward. It's the same beautiful partnership that lets a swimmer glide through water or a bird fly through the air.
And this idea also busts a huge myth about space travel. A rocket does not need air to push against. It works in a complete vacuum because its engine violently throws hot gas out of its back. That's the action. The gas, in turn, pushes the rocket forward. That's the reaction. It's a totally self-contained system pushing against itself to reach the stars. Pretty cool, right?
Okay, so we've covered the why of motion, the big ideas about stubbornness and partnership. Now let's get into the how much. This is the part of the script that lets us actually calculate and predict motion with numbers. Let's think of it as playing the motion math game.
You've probably seen the famous equation, F equals ma, 1,000 times. But where does it actually come from? Well, fun fact, Newton didn't start there. He began with a more fundamental idea called momentum, which you can just think of as an object's quantity of motion. He said that a force is simply what's required to change that momentum over time. And when we simplify that core idea for everyday objects, stuff whose mass doesn't change, we land right at that classic formula. Force equals mass times acceleration.
So let's see it in action. It's actually beautifully simple. If you apply a force of 10 newtons to a 2-kilogram block, the equation tells you exactly what's going to happen. The block will accelerate at 5 meters per second every single second. It's direct, it's predictable, and it's incredibly powerful.
And we can use it to solve a slightly trickier problem, the kind you might see on an exam. Let's say an object's speed changes over a certain time. Well, first, we find its acceleration.
Here, its speed changed by 4 meters per second over 2 seconds. So that's an acceleration of 2 meters per second squared. Then we just plug that into F equals ma to find the force that made it happen. A 2-kilogram mass accelerating at that rate? It requires exactly 4 newtons of force. Done.
So, we've read the script, we understand the rules, and we can play the math game. Now, let's put it all together. Let's talk about how to use this knowledge to crack the physics code, especially for those of you who might be studying this for school or for big exams like YAC and JAMB.
All right, listen up, because these are the absolute game changers, the common traps you need to avoid. First, if you see the words constant velocity in a problem, a little alarm should go off in your head. That means zero acceleration, which means the net force is zero. Always check your units. Convert grams to kilograms before you do any math. And remember the identity check. Mass is constant everywhere. Only weight changes. And please, never, ever forget that action-reaction forces are a partnership between two different objects. They never act on the same body.
And this right here just shows how these abstract laws are written into every single moment of our lives. A seatbelt is literally a first-law device designed to fight your inertia. Pushing a full shopping cart versus an empty one, that's you doing a daily experiment with the second law. And the simple joy of jumping up, that's the third law in action. You push the planet down, and the planet pushes you up.
So, the big takeaway here is that Newton's laws aren't just for a physics class. They are the fundamental rules that engineers and architects use to design everything from skyscrapers to spacecraft. They are the invisible script of our physical world, and now you know how to read it. The only question left is, what are you going to build with it?